In this exercise, we're going to discuss assembly constraints. In previous exercises, we've talked about sketch constraints, and now we're going to talk about assembly constraints. To me, this is one of the great injustices inside of Inventor. It's very confusing to new users, and even sometimes confusing to experienced users if you're talking to somebody or you're discussing a problem or something. The fact that there are two different types of constraints that do two totally different things. So the assembly constraints are how we put parts together. And really and truly, it's about removing degrees of freedom. And what degrees of freedom are, it's best to show you, is you can actually turn on this tool called Degrees of Freedom under View and see what degrees of freedom this particular part has. As you can see, this part has all 6 degrees of freedom. Basically, degree of freedom is which direction it can move. So this part can move in the x-axis, and I know that because of my little UCS down here. It can move in the y-axis, and it can move in the z-axis. Well, not only can it move, but it can also rotate about those axes. So if I come in here and look at these other parts, you can see that all these parts are free to move any direction they want, with the exception of this one. This part cannot move in any direction because it's locked down. All of its degrees of freedom have been removed. If I come in here and I constrain this, and I say that part constrained to this part, you can see there, my degrees of freedom are all gone except for the z-axis and the rotational z-axis. And I'll hit OK here. What that means is this part can move up and down, and it can spin. And I'll do one more here so you can see it a little bit easier. I can constrain using the insert constraint, that part there, and that part there. Hit OK. So now what has happened is this part is locked in all axes but can rotate. This part here can move and rotate in any direction. So you can see that we're removing these degrees of freedom. Now the best way to think about this in Inventor is this is how you assemble things. We take this little snap ring and you snap it in there, and what that allows is then that bushing can then rotate, but it can't move in and out of this part. Same with this little sleeve here. You slide this little collar on here, and that allows this collar to slide up and down and rotate as this arm rotates inside of a socket, and it can move freely. And I think they consider this like a little bearing or washer or something like that. So it would let it spin around, and that's the idea behind it. So we want to remove as many degrees of freedom as possible. If you remember the robot in the previous exercise, when it could move around, and I always say it looks like the little sales guy outside of a lot of businesses, the little air blowy thing that flings around in the air from the little fan. You got to be careful with that robot. And then we can take a look at it real quick here again. So if we take a look at this, you can see here, he just kind of goes all wild. And that's because he still has some degrees of freedom, but others have been locked down. And that's essentially what the constraint is doing. It's removing degrees of freedom so that the part can be assembled. Just like in the real world, you'd put in pins, you'd put in bolts, you'd use glue, different things to remove degrees of freedom from an object. This is different from AutoCAD, where AutoCAD and tools like that, they don't understand that objects are locked together. They don't understand that relationship. You can lock objects, you can lock layers with objects with AutoCAD, but it doesn't understand that that object has a relationship to another object. So by using these assembly constraints, we can give these relationships from one object to the next. And I know these relationships exist, not just because of the way it moves around, but if I expand out my part, I can actually see these relationships. So I can see this part is grounded, and then I can see that it has an insert. I can also come up here to the view and actually see my degrees of freedom that are left. You can see some of them have quite a few. For example, this robot clamp here has very few degrees of freedom because all of these constraints on here. You have a couple mates, flushes. You see all these insert constraints. So you can see these different parts have different constraints to lock down that degree of freedom. So remember, if I say a constraint and we're talking about putting something together, we're talking about an assembly constraint. If I say something about a constraint and we say, for example, perpendicular or parallel or tangent, most of the time those are sketch constraints involving sketch geometry. So whenever I talk about assembly constraints, I talk a lot about things like mates and flushes angles, insert. There is a tangent inside of here, but it's actually a moving constraint. And then you have motion constraints and transitional constraints. So the constraints are a very useful tool to add some design intelligence to our assembly. You want to lock your parts down as much as possible with the proper constraints. And a good proper constraint is going to give you the most intelligent model that you can. So take a look at the design robot and look at the degrees of freedom that it has. So go up to View, toggle on and off the degrees of freedom, and you can see how this part still has some degrees of freedom. And maybe even drop in a new part or two. We practiced this last time. We could drop in some new clamps or something like that. And you can see those are fully constrained. So those haven't had any constraints to put to them, and drag these around versus dragging around a constrained part. So you can kind of see how this works. Play with it, get familiar with it. This is going to be very important down the road. You're going to be doing a lot of assembly constraining. This is one of the more important jobs in Inventor that you do a lot of. Unless you're just designing one part at a time and that's your only job, you're going to be doing a lot of assembling, and assembly constraints are what allow you to do that.